Hello, my name is Mr. Asbury and this is Edexcel IGCSE, this is Histograms, and check out my live revision session to help people get grade 9s. Link in the description. Okay, so what do we need to know for histograms? We need to know, and that is the frequency density is equal to the frequency divided by the class width. So, in this instance, we would write frequency density, a little table, a little column on the side, and we would take the width, which here goes from 0 to 10, which is 10, and we would take the frequency, which is 8, and we'll do frequency divided by class width. 8 divided by 10 is 0.8. Next one, the width is from 10 to 15, which is 5, and 13 divided by 5 is 2.6. And then here we're going from 15 to 25, so that's 10, and 19 divided by 10 is 1.9. Here we're going 15, and 24 divided by 15 is 1.6. And then finally we've got here 20, we're dividing 6 by 20, which is 0.3. Okay, great. So now we go down and we plot. So the first interval is between 0 and 10, and that goes up to a frequency density height of 0.8, which is right here. So I draw a line across like that, and then a line down there. The next box is between 10 and 15, and that has a frequency density of 2.6. So I go up to 2.6, which is about there, and then across only 15, which is there, and then down again like that. Next one is 15 to 25, and it goes to 1.9. So from here we go from 15 across to 25, and then we go down, and then we are going from 25 to 40 at 1.6. So 1.6 is here, so that goes all the way to 40. And then finally we have 40 to 60, and that's 0.3, so that goes all the way along there. And there we go, there we have it, perfect. Okay, so it now says that Manuel selected at random a flight that was late by 25 minutes or less from his results. So how many were 25 or less? Well, if we go up here, that would include 19, 13 and 8 people. That's how many people he selected from. And then what's the chance that out of those people they were 5 minutes or less? Well, out of those people, the ones that were 5 minutes or less is going to be exactly half of this group, because we only want to go from 0 to 5. So therefore there will be 4 people. So it's going to be, the probability is going to be the 4 people here out of the total people he interviewed or selected from, which is 8 plus 13 plus 19. So the calculation would be 4 out of 8 plus 13 plus 19, which is going to give us 4 out of 40. And then also note that they do say an estimate, which does confuse some students, and that estimate is because we have kind of guessed that from 0 to 5 will be exactly 4 people. We don't know where those 4 people are in that interval, but we're going to assume, we're going to guess that the interval is nicely spread out and half the people are in the first half, the other half are in the second. Okay, next question. We've got the histogram drawn for us, but we don't have the frequency density. But it does say that 63 of the parcels were delivered were between 0.5 and 1.2. Sorry. So that is this whole group here. This is between 0.5, sorry, and 2. So this is the whole group that we're talking about. So in there we have 63. So that's the area And the second important thing that we need to know about histograms is that the frequency is equal to the area. So because the area is, of course the frequency is 63 there, the area is 63, which means I can do 63 divided by the width, which is 1.5. And that tells me that the frequency density, or the height of the bar, is 42. So if that in there is 42, it means this grey line here is 40, this one here must be 30, this one must be 20, this one must be 10. And we've now got our scale. So it says work out the total number of parcels that the postman delivered last Monday. So we just got to go through and work out the areas of each of these bars now. So that to me looks like 18 so that is 18 times 0.5, in there is 9. This next one has a height of 24, and it has a width of exactly 1, so 24. This one has a height of 30 and a width of 1, so 30. And this one has a height of 8 and it has a width of 2, so 16. So the total amount will be all of these added together, so we'll do 9 plus 63 plus 24 plus 30 plus 16. And of course in the exam I would absolutely write down that calculation, which would look like this, and then the final answer is 142. It says they pick at random 2 of the records of the parcels he delivered last Monday. Work out an estimate for the probability that each parcel weighed more than 2.25. Okay, so we need to first off find how many weigh more than 2.25. So we go back up to here, and let's just move this slightly out of the way. And we need to find 2.25, which is going to be 1/4 of the way into this region here, like that. So that is about 2.25, so it's 2 1/4. So we need to split this region up, and we're going to split it up into quarters. So we've got 1/4 of 24 is 6, and then on the other side we've got 3/4, which would therefore be 18. So now we can work out more than 2.25. There are 18 plus 30 plus 16. So we do 18 plus 30 plus 16, which gives us 64. Okay, so there are 64 that are more than 2.25. He picks 2 of them at random. So the first one he picks, you've got 64 out of 142 for it to be more than 2.25. And then the next one, there's only 63 now out of 141. So that's the calculation we have to do to get 2 of them above 2.25. So I'm sure that would catch some people out. So the answer is 672 out of 3337. This question requires 2 pages. So we have that the histogram represents the number of hours that they spent on their homework, and no student spent longer than 9 hours, so that's all the students we need to look at. And it says that we need to use the information in the histogram to complete the table, and then work out the mean amount of time. Well, this one, we know all the stuff on the histogram, that's fine, but we need this is the only bit of information we have from the table, so we can write in here that this bar here has an area of 28 because it has a frequency of 28. So if that's the case, then we can, because it has a width of 2, it must have a height of 14, because 2 times 14 is 28. So we know that's 14, and then we could just kind of work out that every box looks like it's going up in 2. So let's just hope this works. It should work, and it does work. Yep, that's fine. So we can go up in 2 as well, like so. They're never going to do like too crazy a scale, so you know, you're pretty much going to be fine. Okay, so now what we need to do is work out all the areas. So okay, 20 is this height and the width is 2, so that's 40. This width is 1 and it's got a height of 30, so it's 30. This has got a width of 1 and a height of 24, so 24. And this is a width of 3 and a height of 12, so 3 times 12 is 36. Okay, so we can put that into the table now, and then we need to just use our knowledge of frequency tables to work out the mean. So what we do is we do the midpoint times by the frequency. So the midpoint here is 3. No, it's not. It's 1. This one's 3. This one's 4.5. This midpoint is 5.5, and this midpoint is 7.5. So we take the kind of average value within the interval and use that, and then we multiply it by how many things there are in that interval. So this gives us 28, this gives us 120, this gives us 135. I don't think I want to do all this in my head. Let's go to the calculator, shall we? Yes, let's do that. Okay, let's move over there, get the calculator out, and in order to find the mean, we have to do this calculation. So we add up all of the frequency times midpoints, and then we divide it by the sum of the frequency, which will be 28 plus 40 plus 30 plus 24 plus 36. And I can do that in one calculation on my calculator, that's fine. So just do this, and then press enter. And this is our value. So to 3 significant figures, this is equal to 3.34. Bosh. So here we've got an incomplete table and an incomplete histogram. So what we're going to need to do is match up some of the information. So from 0 to 10, we actually know that box here, so we can use this one. Because we know that the frequency is 40, which means the area is 40. So if the width is 10, well, the height must be 4 in order to make an area of 40. So if that's 4, then that's 2, which means that's 6 and that's 8. And then obviously that's 7, 5, 3 and 1. Okay, so now let's work out the area of this one here. So that has a width of 5 and a height of 7. So 5 times 7 is 35. This one here has a width of 5 and a height of, be careful here, that's 7.8. So we'll need to do 5 times 7.8, which is 39. And then this one here has a width of 10 and a height of 5.6. You see that each small box is 0.2, so that is 5.6, and that needs to be multiplied by 10, so obviously 56. Okay, and then finally we need to draw the last one on. So it has a width of 30 and it has a frequency of 30, so 30 divided by 30 is 1, so it's going to go along at 1, and it's going to go all the way from 30 to 60, and that is a area of 30. Okay, so the final part says that someone is picked at random, work out the probability that the distance travelled to work was greater than 25. Okay, fine. So what we need to do is we need to draw a line down at 25, and that splits this bar in half, and that bar is worth 56. So what we'll do is we will halve 56 to get 28, so we'll put 28 on either side, like so. Now we are looking at all the people greater than 25, so we want this one and we want this one as well. So that's everyone to the right greater than 25. So therefore, overall, there are 28 plus 30 people in that category. Out of, because it wanted the probability, all of the people, which would be the sum of the frequency, which is 40 plus 35 plus 39 plus 56 plus 30. So we just put that into our calculator and we get exactly 29 over 100. Perfect. So we'll go down here and we'll just write 29 over 100. Job done. Okay, next question. We've not got the frequency density, so we're going to work that out ourselves. It says the histogram gives information about the weights of watermelons. There are 16 watermelons with a weight between 8 and 8.5. Perfect. So this little bar in here is between 8 and 8.5, and that bar there is equal to 16. The area is 16 because the frequency is 16. So that has a width of a half, so therefore it must have a height of 32, because 32 times a half is 16. So I think this big bar here is 30, which will make this one 20, which will make this one 10, and then back down to 0. So that works perfectly. Okay, so it says work out the total number of watermelons in the field. Fine, we just need to work out the areas. So we've got 1 times by 15 is 15. Here, this is 1, because 8.5 to 9.5, times by 23, it looks like. So 1 times 23 is 23. This is also 1, 9.5 to 10.5, and it's got a height of 30, so that's just 1 times 30. And this one is 1.5, and it has a height of 12. So 1.5 times 12 is 18. Yeah. Fine. So the total watermelons in the field is just the sum of all of these, which equals 102. Job done. So here again, we've not got the frequency density scale, so we need to work that out ourselves. So we need some information, and it says there are 12 that are between 75 and 85. So this bar here is the one which we have the information for, and this one is 12. So we just write 12 in here, that's the area, and that has a width of 10, so therefore it must be 1.2. That's interesting, that's 1.2 going across there. That's not the nicest of scales I've ever seen. So I'm going to say that this must be 1, and therefore this will be 0.5. This is a really nasty scale, and that's 1.5 then, and that's 2.0. Does that work? Yeah, that does work. Yes, that does work. Okay, fine. Yes, that works. Do I need to explain that? Well, you just kind of see it. That's 1.1 in there. So then we go down. So each each tenth takes up 2 squares. So that's 0.9, 0.8, 0.7, 0.6, and then down to 0.5, 0.4, 0.3, 0.2, and 0.1. Yes. Okay. It says find an estimate for the probability that... Okay, so one of them is selected. So we're going to need to know the total anyway. So we've got to work out the total to find the probability. So that's 0.6 times by 5, which is 3. This is 10 times by... that's 0.8. So 10 times 0.8 is 8. This is 1 height, and it is 5 width, so therefore that's 5. This has a height of 0.4 and a width of 5, so 0.4 times 5 is 2. perfect. So the total frequency is going to be useful. So 3 plus 8 is 11, plus 5 is 16, plus 12 is 28, plus 2 is 30. And then it says we need to find an estimate for the probability that the height is greater than 82.5. Well, where's 82.5? Well, there's 80 and there's 85. So it's going to be halfway between there. So we're going to draw a line down here, and this is going to split this bar up into, 1/4 over here, and 1/4 of 12 is 3, and then 3/4 over here. So 3/4 of 12 is 9. Okay, perfect. So greater than 82.5 is going to be 3 and this 2 here. So the total probability will be 3 plus 2, which is 5, and the probability will be equal to 5 over 30, the total amount. You could simplify it if you wanted to, or you don't need to, because it doesn't ask you to. Hope you enjoyed that. See you in the next one. Bye for now.